Today we're going to be talking about redox reactions and their role in single replacement reactions. So what exactly does the word redox mean? It's actually a combination of two words used in chemistry. The first being reduction, and the second one, oxidation. Redox reactions focus primarily on the transfer of electron particles in a reaction. So let's go over what reduction and oxidation are. In oxidation, electrons are lost during a reaction, and in reduction, electrons are gained. Now that we know what these terms are, let's observe them at work in a reaction. Let's say we take iron 3 oxide, or rust, and aluminum powder, and react them together. By reacting these two substances together, we would get iron metal and aluminum oxide as our products. So let's talk about something called a half reaction. Half reactions are used to state if something is being oxidized or reduced. To write them, we must first label each element with their respective oxidation number. Any element that exists by itself has a charge of 0. So now that we wrote up the numbers, what are we going to do now? To get more space, I'm going to transfer this reaction upwards on the board to have more space to write out the half reactions. If you're having trouble remembering which gets oxidized or reduced, you can use Leo or Gur to help you remember. If we look at iron in the reaction, we notice that it goes from +3 to 0. So we can write its half reaction as it gains 3 electrons and becomes more negative. Now for the aluminum, it goes from 0 to +3. So we know it's becoming more positive, so therefore it's losing 3 electrons and being oxidized. To reiterate, the iron is becoming reduced because it gains 3 electrons instead of losing 3. So we can write its half reaction as it gains 3, so it becomes Fe0. This specific reaction is known as a thermite reaction. It releases a lot of heat and isolates a single metal. To give you an insight about what this reaction looks like in real life, I performed this reaction in my backyard for you. I placed the two reactants inside a ceramic flower pot and lit a magnesium ribbon inside. The magnesium ribbon gives off enough heat in order to start the reaction. As the reaction progresses, you'll notice that the iron ore generated in the reaction comes spilling out the bottom of the flower pot. The aluminum oxide generated will either cling on to the ore or remain at the bottom of the flower pot, like so.